Howdy, intermediate algebra students. It's time for our last flipped classroom lesson from Chapter 12, Solving Rational Equations. And of course, we save the best for last. This is the most practical use of all this stuff we've been studying about, even though it might be the most difficult. Well, we're going to be solving equations. We all know all about solving equations. Our goal, of course, is to get the variable by itself. So in this particular equation, we're going to be trying to solve for r. But more importantly, in this case, our goal will be to knock out the denominators. It's going to be hard for us to solve an equation like this until we get rid of those rascally denominators. So, if you look here, I'm trying to look for a number that I can multiply that will knock out 4, 5, and 3. So I'm trying to think of some number that might do that for me. And I think my least common denominator, that number that's going to do it for me here, might be a number like 60. So what I'm going to do is multiply everything here by the number 60. So I'll put it out like this, and then I use the distributive property like this, and so I have 60 times this. Now I do notice that 4 here can be divided into 60, and in fact 60 divided by 4 is 15. So I'm going to have 15 times 2 minus r. And then I'm going to do the same thing and multiply 60 by this fraction. And then I notice that 5 can go into 60 12 times. So I have 12 times 3r. And finally, I can't forget about multiplying 60 by this last expression here. And I see that 3 goes into 60 20 times. So I'm going to have 20 times r plus 2. So as you can see, this is kind of involved, but at least now we don't have any denominators to worry about. So now I'm going to keep trying to work on this. 15 times 2 is 30 minus 15r plus, I can multiply these together to give me 36r equaling, well, 20 times that expression will be 20r plus 40. I can simplify my left side a little bit here. I have a 36r minus 15r, so that's going to give me 30 plus 36 minus 15, I think, is about 21. So I'm doing pretty good here. Now I'm going to try to get all my variables on one side, so I think I'm going to change colors here so you can see what I'm doing a bit better. I'm going to subtract 20r from each side. And since I'm running out of room, I'm going to do another sneaky thing. I've got all my r's on the left. Now I'm going to try to get all my variables on the right. Or excuse me, all my variables on the left. So now I'm going to try to get all my numbers on the left. So now I'm going to subtract 30 from each side. Usually we don't do this in the same step, but I think I'm going to try here just for the sake of simplicity. So now what I'm going to end up with here, way at the bottom of the slide, notice on the left side the 30s are gone. 21r minus 20r is just plain r, or 1r. And on the right side those r's are gone, and 40 minus 30 is 10. So there's my answer, r equals 10. A little bit of an involved process, but not too much. The problem that we're going to look at. Notice this one now has variables in the denominator and not numbers. So I have to think of, once again, a common denominator or a least common denominator that when I multiply everything by it, it will knock out those denominators. Now, you might say that it's going to be just k plus 1, but remember, when I am multiplying by k plus 1, that's not going to allow me to cancel these out because of the addition right here. So I'm going to have to add an additional thing to this. I'm going to multiply actually by k times k plus 1. In other words, that's my whole gamut of denominators there. So when I multiply this times this, notice that the k plus 1s will cancel out. What I'll end up with then is 4k. When I multiply this times this, my k's will cancel out. I'll end up with minus 5 times k plus 1. And lastly, when I multiply this by the value on the right side, again, the k's will cancel out, and then I'll have 3 times k plus 1. Well, again, not a real beautiful looking problem, but at least I don't have anything left in the denominator. So now I'm just going to go to work here and take 4k. I'm going to distribute the minus 5, so minus 5k minus 5. Remember, when I take minus 5 times 1, that's going to be minus 5. Meanwhile, over here, that's going to equal 3k plus 3. Make sure to tell me if I make any mistakes here, Elizabeth, while you're watching this. Now I'm trying to simplify the left side, so I get minus 1k minus 5 equals 3k plus 3. I'm going to get all my k's on the left. I'm accustomed to doing that. So I get minus 3k there. So here I'll have minus 4k minus 5 equals 3. And I'm going to add 5 to each side. I'm almost done here, boys and girls. And so I get negative 4k equaling 8. I'm going to divide both sides by negative 4. I'm running out of room here. And sure enough, I get that k equals negative 2. So there's my answer for that. Again, kind of tricky, a lot of work involved here, but good problem nonetheless. Practical problems here. So notice it says I can ride my bike 15 miles per hour in calm air. That might be a bit of an exaggeration. With the wind, I can ride 50 miles, and the same time I can ride 20 miles against it. Find the speed of the wind. Well, remember our famous formula, distance equals rate times time. So if I wanted to solve this for t, because the times are the same, I could divide both sides by r, and then I would get, what I'd have left with then is that the time equals d over r, the distance divided by the rate. Now I've made this chart here, which is probably a good idea for these kind of problems. I'm just going to write an expression for the time in each of these. So the time in this case will be 50 over 15 plus w. And on the bottom one, against the wind, it'll actually be, I think I forgot to change this. This should be 10 instead of 20. I didn't make that change up there. 10 over 15 minus w. Now I'm going to go to the next slide and work this out when I have a little bit. This is just a blank slide. So if the two times are the same, what I have is 50 over 15 plus w, and that's going to be the same time as 10 over 15 minus w. Now, we haven't worked a lot with this, but last year when you worked with ratios and proportions, what we have here are two fractions. You may remember that when you have two fractions equal to each other, you can do some cross multiplying. We did a little of that this year, but not a whole lot. So that means I can say that 50 times 15 minus w is going to be the same as 10 times 15 plus w. Then I can distribute this out. This is actually going to be 750 minus 50w equals 150 plus 10w. I'm going to get all of my w's, I think, this time on the right, so I'm going to change pen colors here. So I'm going to try doing this. I'm going to add 50w to each side. And at the same time, I think, just to make things a little bit nicer, save a little bit of room, I'm going to try to get all my numbers on the left. So that means I'm going to subtract 150 from each side here. Now, notice what I have left after I've done this then. So on the left side, I have 600. My w's are gone. And as far as the numbers go, I have 60w. So I can divide both sides by 60. And I get that w equals 10. So the wind is 10 miles per hour. So kind of a slick way to be able to figure that out. Okay, one last problem here. This is again kind of a famous type of problem with rational expressions. It says Emmett can clean the hog barn in 2 hours. Chauncey can clean the same area in 4 hours. How long would it take them if they worked together? Now, do you think it'll be 3 hours, halfway between 2 and 4? Let's find out. Well, does it make sense that if Emmett can clean the hog barn in 2 hours, that if he has a certain amount of time, I can write that fraction of a time that it's going to take him as t over 2. Because if he works for 1 hour, that's 1/2. You'll get 1/2 of the job done. This is the fraction of the job that he's going to get done in 2 hours. Same thing with Chauncey then. He can get it done in 4 hours. So the fraction he can get done will be written like this. I'm going to add these up since they're working together, and it's going to equal 1. 1 standing for 1 job. Well, this is a problem like we started with a little bit earlier. I want to knock out these denominators, so I'm going to multiply by something that will knock each of them out, probably a number like 4. And when I distribute that, I see that I'm going to end up with this. 4 times this, the 2's will cancel out here. So I'm going to end up with 2t. And when I do this, the 4's will cancel out, so I'll get just t or 1t. And again, don't forget to multiply the 4 times the 1, which is 4. So what I end up with here then is 3t equaling 4. I divide by 3, and so the time it's going to take him to complete this job is 4/3 of an hour. Now, 4/3 of an hour, you can write that as 1 1/3 hours, which is the same as 1 hour and 20 minutes. All right, thanks for hanging in there during this video, and we'll see you guys in class tomorrow. Bye now.